Good morning, everybody. Thank you for joining us on this very beautiful Saturday morning. Today we celebrate the International Day of Mathematics 2024. My name is Lungile and I will be your host for the next 2 hours. Of course, I'm never alone. I am with my beautiful co-host, Dr. Serene Ratalal. Serene, good morning. How are you doing today?
Morning, Lungi. I'm well, and you?
Oh, I'm okay. It's Saturday, but I'm okay. I'm good.
It's Saturday, and we've got an exciting program lined up, right?
Yes. So do you want to tell us exactly what we're celebrating? Because I did say it's the International Day of Mathematics. But what is the fuss about today, especially in the mathematics community?
So historically, what we're celebrating is known as Pi Day. And actually, as recent as 2019, it was that the International Mathematical Union had attended a General Assembly meeting, and through UNESCO, it was then proclaimed that we would be celebrating the newly called International Day of Mathematics. So we know that pi, it's approximately 3.14. So that 3 represents the month of March, and the 1 4 represents the day.
Okay, so if that's the case, then why are we celebrating today, which is the 9th, and we're not celebrating it on the 14th?
So actually, we're celebrating International Day of Maths, which is 14th of March, but of course, now we're hosting it on the Saturday. So we've got lots of celebrations taking place across the month. This is a global celebration. And so in particular, we're hosting this event on the 9th of March. And for example, University of Pretoria has some other events on the 13th and 14th. UKZN has another event on the 14th. There's lots of things, and students could go to the IDM website to take a look at what is happening globally.
Interesting. I have to share with you the other day I had a blonde moment while we talk about pie. My sister said to me, Pi Day is coming up. And I was like, Pie Day? You want a pie? I'm gonna
Oh,
be eating pie. And she's like, no, Pie Day. I'm like, it's Pie Day. So now that we talk about 3.14, I'm remembering now Pie Day. So Serene, do you want to tell us about today? What should we expect on the program as the lineup? Do we have anything fun, exciting? Anybody who's gonna be showing us some magic?
absolutely. We always have a fun program. You know that. This is our third annual IDM celebration. So, for those of you who attended last year, I think you would have been enticed by some of the math magic shared by Dr. Claudette Robinson. Well, she's back this year. And
Mm.
this year, she's talking to us about mathematical numbers. In addition to Dr. Claudette Robinson from UJ, we have Professor Magendran Govender from DUT. And you can expect a spectacle, a show, because today he's talking to us about the flying circus of mathematics. In addition to that, Lungi, we're also having an exciting fireside chat with Dr. Shavara Hansraj and some undergraduate students. So that's something I'm also looking forward to.
I'm quite excited because growing up, maths was really boring. So for me, it's exciting to see people bring maths to life. So this magic. And yeah, I'm really, really excited about today. So Serena, I think you wanted to ask me about the logos. Right. So we do have a lot of logos you'll see on my background, everyone's background who you'll see today. The poster that has been out for the last couple of weeks and in anticipation for today. So we do have quite a number of logos on there. And those all represent our wonderful sponsors who are also our partners. So we have the University of Johannesburg, we have University of KwaZulu-Natal, we have the National Institute of Theoretical and Computational Science, which is NITEX. We have Vodacom, we have Actuarial Society of South Africa, South African Mathematical Foundation, South African Mathematical Society, and the Matric Helpline. So we are quite a hit. I mean, we've got a lot of partners, but the exciting thing about our partners is that they're also very generous. So this year they are sponsoring quite a number of prizes. So those of you who are on here, please stay on, don't fall off. Please make sure you participate. You would have seen when the program is up, we have 2 quizzes in the program. So these are really exciting quizzes. So there are lots of really great prizes up for grabs. And also for participating, there will be a random selection of participants, and somebody today will go away with a really nice Vodacom hamper. So Serene, do you want to say anything else about the prizes?
So is that Vodacom hamper like a lucky draw?
Yes, so the Vodacom hamper is a lucky draw. So random selection of any participant who participates in the quiz. So you have to make sure you participate in both quizzes, and then your number could be drawn, your name could be drawn as a lucky draw, and you can win yourself a really nice cool Vodacom hamper.
Oh, that's exciting. I also just want to mention that for our quizzes, just so that you are all prepared, because of course there's two of them, it's advisable, Lungi, that the student would have a secondary device so that they could play the quiz from a cell phone while they view the questions on our screen. So maybe in preparation, you may want to do that. Maybe you'd also want to get pen and paper because by the time we get to the second quiz, it's going to get challenging. So you're going to need every bit of help you can get there. But yeah, that's the quiz, and you can expect that to happen. The platform we're using, Lungi, is Kahoots. So just so the student knows, I will explain the procedure when the quiz is about to start. But on your secondary device, you would go onto the Kahoots platform and enter a PIN. But no stress, we will review this again in the next 15 to 20 minutes.
Okay, perfect. So they must just make sure they have at least two devices. So for those of you at home, please make sure you ask somebody at home, your sister, your brother, your mommy, anybody, to just borrow you their device for the quiz. And be ready, right? Be ready. Have those quick fingers. All right. So before we get into today's program, we do want to go over a few ground rules with you. So please make sure we have two places. We have a Q&A and we have a chat box. So for all your questions, and we really invite you to engage with our really cool speakers through your questions, please type in your questions in the Q&A box and we will make sure we try and answer those. And then for anything else, just to tell us how fabulous we are or how boring we are, you can do that in the chat. But please make sure no profanity, no biting, kicking, nothing funny. This is a safe, respectable place. So if you have nothing nice to type, keep it to yourself. All right. So, Serene, I think I will hand it over to you to start off our program for today.
Thank you. I'm excited to introduce our first speaker, and that is Professor Gareth Amery, and he's going to be doing a welcome. So Professor Gareth Amery is the academic leader of mathematics at our School of Math, Statistics and Computer Science in Durban. He trained at the University of Natal and Cambridge as an applied mathematician, and he has a diverse range of interests, having worked on applications in theories of gravity, computer science, pharmacology, and mathematical biology. He is a strong advocate for the power of mathematics to effect social and economic change. Thank you, Prof. Amery. I'll hand over to you.
Thank you very much, Serene, and good morning to everybody. It gives me great pleasure to welcome you all, learners and teachers alike, to this International Day of Mathematics event. From first concept back in 2020, through to the first events hosted by UJ, and up until this day, this initiative of the Future Mathematicians Programme is a welcome, necessary, and very urgent intervention. Mathematics is critical to all science, technology, and engineering education. And indeed, it is my firm belief that education and training about how to reason effectively is a critical part of advanced citizenry, for it makes you able to make better choices. And when citizens make better choices, our democracy is a healthier democracy. And this before we even get into the practical utility of having a solid foundation in the mathematical sciences. UKZN recognizes this and is placing mathematics and STEM more generally at the heart of its strategic plan for the next 10 years, and indeed at the heart of contemporary projects to renew our offerings and our services to our students. In this case, it is investing in the resources to drive mathematics education and research. We have a large and very diverse group of staff pushing the scientific boundaries, both in education and in research. And our applications run the gamut from the obvious in things like engineering and theoretical physics through to less obvious things where one is investigating finding new drugs to combat tuberculosis, for example, collaborating with pharmacology. We work with mathematical biology and computer science very deeply. So pretty much anything you're going to be doing in one's life needs some mathematics. So it's key that we maintain this strength, and key to doing that is to maintain and generate interest through programs such as this. To do that requires support, and I'm glad that our sponsors have already been highlighted. I wish to thank them again, especially our corporate sponsors for their generosity, and our partner institutions for making this more of a national program. I think it's an imperative and very helpful event. Personally, and on behalf of all involved in organizing this, I want to thank Dr. Rathilau and her team for driving this. I think that they have done an excellent job and should give you a very positive experience. So without further ado, welcome to the International Day of Mathematics event. You have an excellent program with some exceptional presenters. I know them well. May it be a wonderful experience that opens doors and eyes. Back to you, Serene. Have a great day.
Thank you so much, Prof. Emery. Thank you so much for the welcoming. And you are absolutely right. It is such a great time to have such conversations about mathematics, especially in our country now where mathematics, what we are seeing in our high schools is quite disturbing when it comes to mathematics. Okay, so let me not waste any more time. It's time for the maths magic. So I'm going to introduce our next speaker. So our next speaker is Dr. Claudette Robinson. Dr. Claudette Robinson holds a bachelor's degree in mathematics and chemistry and an honors degree in mathematics. She also holds a master's and a PhD in mathematics. She is currently a senior lecturer at the University of Johannesburg, and she is in the Department of Mathematics and Applied Mathematics, where her research focus includes universal algebra and lattice theory. All to you. Over to you, Dr. Claudette.
Thank you very much, Lungi. So in today's talk, I am going to perform a couple of magic tricks, and they all involve some very special numbers or magical numbers, if you want to think about them like that. And I know they usually say that the magician never reveals its secrets, but I thought that today I will show you the magic or the mathematics behind all these tricks, just to demonstrate the beauty of mathematics, and also so that you can go and take these tricks and show them to your friends and family and impress them with your magical and mathematical skills. So before I start, maybe grab a piece of paper, a pen, and your calculator. And also feel free to put your answers in the chat so that we can see if you get these answers, or if I'm going to guess the correct numbers here. So for my first trick, I am going to attempt to read your mind. So I want you to start by thinking of a 3-digit number where all the digits are the same. So for instance, 111 or 222. So if you want to write it down on a piece of paper. Okay, so in the next step, you have to add the digits together. Okay, so now divide the number that you chose in step 1 by the sum that you obtained in step 2. Okay, so I think that this should be your answer. And if you did it correctly, this will be the answer that you always get if you perform those steps. So how do we get this? Well, in the first step, you were asked to think of a 3-digit number where all the digits are the same. So we can write this number as AAA, for instance. And then if we write that in expanded notation, it becomes 100A plus 10A plus A, which is then equal to 111A. Now, the trick that I'm using here is that we know that we can write 111 as 37 times 3. So now you should be able to see why this trick works. So if we now add digits together, we get 3A, and then dividing AAA by 3A, we end up with this 37 times 3A divided by 3A, and then the 3A's, of course, cancel, which gives me the answer 37. So this will always work. Okay, so for my next trick, I want you to think of another 3-digit number, but in this case, all 3 digits must be different. So you can think of the number 1, 2, 3, for instance. Okay, so write it down on a piece of paper. So now take that number and reverse the digits of the number. So if you chose 1, 2, 3, it will now become 3, 2, 1. So notice that the middle number is still going to be in the middle. Okay, so now subtract the smaller number from the larger number. And if you end up with a 2-digit number, all that you have to do is you just add a 0 in front of your answer so that you still have a 3-digit number, but it will have a leading 0, of course. Okay, so in the final step, you have to add this result that you got in the previous step to the reverse of itself. So use your calculator if you have to. So add this number to the reverse of itself. So you have to reverse the digits and add it to the number you got in the previous step. Okay, so I think this should be your answer. No, I think something went wrong. It looks like it's upside down. In fact, I think that is your answer. And again, if you follow the steps correctly, you will always get this number if you perform these steps with a 3-digit number where all the digits are different. So why does this trick work? So again, I'm going to write my 3-digit number as ABC, where the A and B, C are all different, of course. In expanded notation, it becomes 100A plus 10B plus C. And then, of course, if we reverse it, we get CBA, which in expanded form will be 100C plus 10B plus A. Right, so in the next step, I did ask you to subtract the smaller number from the largest number. So for my explanation, I'm going to assume that the ABC was the larger number. So in other words, that A was greater than C. It doesn't affect the outcome. Even if it's the other way around, it will still work. So for now, let's suppose A is greater than C. And then you're going to subtract CBA from ABC. So if I use the expanded form, we end up with this. So we have 100 times the A minus C. The middle terms will cancel because it's the same number. And we will get C minus A, or if we rewrite it, it becomes minus A minus C in a bracket. So what I'm going to do is I am going to call that A minus C a D, just to simplify the calculations a bit. So let's replace that with a D. So now we end up with 100D minus D. So that 100D minus D will definitely be a 3-digit number as well. The reason for that is because A and C are both numbers between 1 and 9. If you subtract one from the other, you should get a number between 1 and 9, which means 100D minus D is going to give you a 3-digit number. And that we can, of course, write as in expanded form as well. So I'm going to rewrite the 100D minus D at the bottom here in expanded form as follows. So you can check this to convince yourself that it is the same as 100D minus D. So in the middle here, I have 10 times 90, 10 times 9, which is 90, plus 10, which is 100. So, of course, 100 minus this 1 here is minus 100. So those will cancel. So you will get 100D minus D, which is what we have at the top there. But this is just going to help me in the final step if I write it in this expanded notation. Okay, so in the final step, you were asked to take that result that you got, then reverse it and add it to the answer you got in the previous step. So when I reverse this, the D minus 1 that sits here with 100 is now going to go there. So we're going to get D minus 1. And the 10 minus D, which will be a 1-digit number between 1 and 9, that is now going to sit here with the 100. If we reverse it, of course, the middle numbers will be the same. So you have 10 times 9 and 10 times 9. And if we add that, these two numbers together, if we look at the numbers in the brackets, we can see that these will cancel, and the -1 plus 10 is going to give me this 9. 10 times 9 plus another 10 times 9 is going to give me 180. And then finally, the d's will cancel again, and we have 10 minus 1, which is 9. Now, of course, if we add those together, we get 1089, the magical number that you always get. Right, so like I said, this will always work because of this proof, no matter what 3-digit number you choose. The key is just that all the digits must be different. Okay, so then in the last part of my talk, I want to tell you about the number 6174. It is known as Capricorn's constant. So what is so special about this number? I mean, if you have a look at it, it looks like an ordinary number. There's nothing special about it. But Capricorn showed that if you repeat a certain process, which I'm going to outline in a few seconds, you will always eventually end up with the number 6174. So how does this procedure work? So you start with a 4-digit number. The requirement here is that at least 2 digits must be different. So I chose the number 3564. In the next step, you will rearrange the digits in decreasing order. So it becomes 6543. Then we take those same digits and we rearrange them in increasing order to get 3456. Now, if I subtract that number from the 6543, we obtain 3087. And now I'm going to repeat the process with this number. So rewrite it so that your digits are in decreasing order. So we have 8730. And then again, we rearrange them so that the digits are in increasing order, and we get 0378. If we subtract, we end up with 8352. So we repeat the process again, and we rewrite the digits in decreasing order. So 8532, and then in increasing order, we obtain 2358. Subtracting, we get the magical number 6174. Now, if we take this number 6174 and repeat the process, so we write the digits in decreasing order, we have 7641, and in increasing order, it becomes 1464. Subtracting, we end up with the same number 6174. So in this case, I had to repeat the process 3 times to get the magical number 6174. Let's take a look at another example, 9218. If we start by writing the digits in decreasing order, we obtain 9821. In increasing order, we have 1289. If we subtract, we have 8532. And if we rearrange those again, we end up with 8532. And in increasing order, they become 2358. Subtracting gives me the magical constant, 4176. And if we repeat this again, like we did in the previous example, we're going to get 7641. And in increasing order, they are 1467. And subtracting gives us the magical number 6174 again. So in this case, I repeated this process just 2 times. And in fact, it actually turns out that this routine will always reach its fixed point 6174 in at most 7 iterations. So I want you to now go and try this same trick with a 3-digit number where at least 2 digits are different. And you will see that like this process that I just showed you with the 4-digit numbers, you're going to have something similar here. You will always end up with the number 495 after a few repetitions. So go and try this for yourself, and you will see in this case, for 3-digit numbers, you will always end up with the number 495 in at most 6 iterations. So that was all that I wanted to show you. And maybe as a last trick that I thought I will share if I have a little bit of time left. Take the number 259, so 259, and multiply that by 39. So 259 times 39, and then multiply it by your age and see what you get. Something magical will definitely happen as well. Thank you, everyone.
Thank you, Dr. Robinson. It's always such a pleasure listening to this maths magic. And for someone like me who doesn't really like math, I'm really not ashamed to say that. It's so exciting. It's really exciting. And I see in the chats as well, you are really getting a lot of hits, commenting on how enjoyable and fun this is, and how amazing mathematics is. And yeah, you really show us that math can be fun. So one of the questions that I wanted to ask you was, what kind of theories should one know in order to be able to get to these tricks? Because, these are not like overnight tricks that one will be able to know. So what theories do you recommend that we know for this?
So, I mean, definitely something that is often used and we've seen this today in these tricks is the fact that you can write numbers in this expanded form. That's always useful. But definitely most of these tricks are based on number theory, which is a big field in mathematics. So, and often sometimes knowing things about prime numbers also help, properties of prime numbers. So yeah, mostly it comes from the number theory field, I would say, which is a very interesting field if students want to go and read up about it a bit and look it up.
So would you say that especially for the younger ones, right? I would just like for you to emphasize how important it is for them to actually start at foundational level, because these are not things that you can know already when you get to university and try to learn them then. These are things you should already be trying to learn from the beginning, from your foundational mathematics. So what would you like to say about that?
Yes, I mean, definitely mathematics is you always build on, like you said, fundamental things. So it's very important, never fall behind. I think that's the most important thing. In mathematics, you can't fall behind. You have to stay on top of everything from the start. And then that is, if you fall behind, you're going to get in trouble. So my advice would be to stay up to date with the fundamentals. Yes, very important.
So I have another question for you here in the chat. One wants to ask, is there a Caprica constant for any 2-digit number or 5-digit number?
I'm not 100% sure about the 2-digit, but I think for 5 digits, yes, but I can't remember what it is. But I mean, you can definitely look it up. But I think there are, if I remember correctly. But I think the two famous ones are the 495 and the one that we looked at, those two.
Okay, one last question. Have you always been passionate about mathematics?
Yes. I have been since school. Yes, I enjoyed mathematics very much. To me, it's almost like the art. There's a lot of beauty in it. Yes. So I think of it as an art. So I have been always have been very passionate about it since school. Yes.
Thank you so much, Dr. Robinson. It's always a pleasure watching your slides and listening to you talk about mathematics and magic. Thank you so much for that. So next up, we have our quiz. So we have our first quiz coming up, which is going to be ran by Dr. Ratilau. Serene, I'm going to hand it over to you.
Perfect. Thank you, Dr. Sitole. All right. So we're ready to kick off the quiz. But before that, let's talk about some important information that we all need to keep in mind. So how will you be able to join the quiz? So in order to do that, remember at the beginning, we mentioned that it's advisable that you have a secondary device. So maybe get hold of a colleague or your parent or a guardian, someone close to you, to use their device while you're still able to look at the screen. You would have to go to kahoot.it and enter the PIN that I will provide, or you can scan the QR code from the screen. Now, I have very special instructions for your nickname, because when you join the quiz, you're going to have to enter your school name as well as your nickname. So the format for your nickname, and this is important because it helps us decide who wins the prizes. Today, we're going to be awarding prizes in 3 categories. You could win a prize if you are in grade 8 to 9, or if you are in grade 10 to 12, or the undergraduate category. So there will be prizes for this quiz in 3 categories. As such, we need you to specify which category you belong to. Of course, we'd be able to verify this at a later point. So we, depending on your honesty, and of course, the format you will follow is you will type in your first name followed by your grade. So it's name followed by grade. So if your name is Sia and you are in grade 8, then your nickname should be Sia followed by 8. If your name is Emma and you are an undergraduate student, then your nickname should be Emma followed by UG for undergrad. So you could put in a space or an underscore or simply type the UG next to your name. That would suffice. So it's basically name followed by an 8, 9, 10, 11, 12, or UG for undergrad. I hope that is clear. You can let me know in the chat box if you need me to explain this again, but this is pretty much the rules to enter your nickname. All right, so Lungi, I think we are on track. Would you like me to explain anything again before we move on?
No, I don't see anything in the chat. So I think everyone is clear. Maybe just give them 1 minute to kind of, get that extra device so they can go to Kahoot. But I think everything was clear. So just another 30 seconds and then we can start.
Sure. So I'll just repeat. For example, my name is Serene, and if I was in grade 10, then my nickname for the quiz is going to be Serene followed by 10. Serene 10. So that's how the nicknames work. What I'm going to do is I'm now going to change my screen, and I'm now going to go onto the Kahoots platform so you could start joining. So here we go. I hope that we could all see this. Lungi, can you confirm that you see it?
Yes, we do. Can you just read out the game pin? Or I can read it out because I see some are asking. So for everyone, the game pin, for those of you using the pin, it's 448774. Again, 448774. So I know there's another question, where do we get the link? So please make sure, go to kahoot.it, then you'll open it up, and then you can use the pin that is on the screen. Okay, nice. Yes, we see everybody getting in. Quite exciting. Be ready, be ready. Be quick too, be quick. Really exciting prizes today.
And just to mention, Lungi, because we had not done this, we want to send a shout out to the students who are watching us physically from PMB campus and Westville, and Howard campus. I think that we have students that are there in the venue. So
yes, that is correct. That's correct. Shout outs to those students. Thank you for watching. Thank you for all sitting in together, waking up on a Saturday morning to get to the campuses and joining us. Yeah. Howard and Westville campus at UKZN. That's correct, right, Suri?
That's right. And whilst we're on the topic, I want to say a special thank you to Matric Helpline at UKZN, especially Lexia Naidu, who's provided us with this Kahoots platform. So thank you for sponsoring this to make these quizzes possible. All right, so we still have many of you joining. Let's give it another minute or two as the numbers rise. Maybe I can tell you a bit more about what to expect in the quiz. So quiz 1 consists of 4 questions. You will see the question on the screen that I am presenting from, and you would have to select your correct option. It's multiple choice. You will have to select your correct option from your device that you are playing from. Okay, so keep that in mind. And the faster you answer, the better for you.
We see it's a very nice number coming in there, Serene.
Mm-hmm.
Serene, so if somebody else has a similar name to another person, it's okay for them to use their second name, right?
Sure, that is fine, but I've also requested that what's not displayed on the screen at the moment is that I requested school. So I would be able to tell apart two different people, so no stress.
Okay, so it's fine. If you are both Sia, go ahead and say Sia for both of you. We will be able to tell the difference when we do the final selection of winners. So it's not a problem.
And we will be verifying the entries with our registrations as well. So we've got lots of things to do in the back end. So no stress. We'd be able to tell students apart.
Okay. So I'm going to read the pin for the last time. 448774. Thank you so much for typing it in the chat box for us. 448774. Okay, so Serene, I think we should be ready.
Okay. I see it's 9:38. Maybe another minute or two?
Sure, no problem. So Nolwazi, no need to raise your hand. Please type in your message in the chat box or the Q&A, and we will try and assist you if you are having a problem that we can assist with.
Okay. Yeah, we still got students joining us. So I think some are joining, some are dropping off. So we'll give you another minute to get on.
I'm excited about it.
Yeah, I've tried it out. It's quite fun, but they're going to have to be quick. And yeah. The difficulty is going to increase as we proceed to quiz 2. So yes, I hope everybody's ready.
How difficult is difficult?
It's relative now. It's relative.
Well, we do have some maths geniuses, I believe, on here with us today. I think a lot of these kids are really sharp, so it's going to be interesting to see.
Okay. Shall we begin? Well, I see the numbers did drop out, so I want to give... Okay, it's 9:40. Okay, it's gone back up. Okay. So 2 people dropped off, 2 people came on in. So I'm about to hit start, so I hope everybody is ready. Let's go. Right, so this is quiz 1, 4 questions. It's starting in 3, 2, 1. What is the 2024 IDM theme? Is it red? Mathematics everywhere. Blue, playing with mathematics. Yellow, mathematics for a better world. Or green, none of the above. Make your choices. 13 seconds remaining. And 5, 4, 3, 2, 1. Time's up. Our theme this year was playing with mathematics. So those of you who had gone to the IDM website that we mentioned at the beginning of the webinar, you would have seen that the 2024 theme is playing with mathematics. Last year's theme, I believe, was mathematics everywhere. Or that might have been 2022. Well, are we ready for question 2? All right, and so we have a scoreboard for us to take a look at who's in the lead after question 1.
Well done, Future Math.
Question 2. What number do you get when you multiply all the numbers on your cell phone dial pad? Is it red? 40,320. Is it blue? 9 factorial. Is it yellow? Undefined. Or green? None of the above. What number do you get when you multiply all the numbers on your cell phone dial pad? 8 seconds remaining. 3, 2, 1. Time's up. And the answer is green, none of the above. Why is that the case? It's because the answer would be 0, because one of the numbers you're multiplying by from your dial pad is 0. Okay, so that was not there to trick you. So I'm glad that both of you got it right. Okay, so let's move on. 2 questions left, Lungi. I'm now handing over to you.
No problem. So let's go for the third question. So, third question, which one of the following partners are our IDM at our IDM event? Is it red, UKZN Matric Helpline, blue, Croxley, yellow, Vodacom, green, UJ Soweto Science Center, turquoise, Actuarial Society of South Africa, or is it purple, STEM Mentor? So remember here, you can select more than one answer. Quick, you have to be very, very quick. 5, 4, 3, 2, what's the answer? Let's see who got it.
So we have multiple correct answers. It's the UKZN Matric Helpline, Vodacom, the Actuarial Society of South Africa, and the UJ Soweto Science Center, for which Dr. Sitole is the director.
So well done to those that got it right.
All right, I'm moving on. Do we want to see who's in the lead now, Lungi? Would you like to see the scoreboard?
I would like to see if it's the same person or not. Let's see. Okay, Mamo undergrad. Okay, well done, Mamo. Last question in this session of quiz. So I'm 4 times as old as my daughter. In 20 years, I shall be twice as old as her. How old am I now? Am I red 20, green, blue 30, yellow 40, or am I 50 green? Red 20, blue 30, yellow 40, green 50.
They might need pen and paper for this one, right?
Yeah. So you have a little bit of time for this one, and I can read it out again too. I am 4 times as old as my daughter. In 20 years, I shall be twice as old as her. How old am I today? This is a nice one. Am I 20? Red, matches my headband. Or am I 30? Blue. Am I 40? Yellow. Or am I 50? Green. Five, 4, 3, 2. What's the answer? How old am I today? I am 40. Yellow.
Wow, okay. And we see that the majority have got it right.
Well done.
All right.
Well done, Mama.
So just to point out, I have mentioned that we are awarding prizes in each of the 3 categories. So don't despair. This is just the 3 highest scoring participants from the quiz today in quiz 1. But we're going to be going back to the quiz report, and we are going to view who is the highest scorer in the grade 8 to 9 category. We're going to pick the highest scorer in the grade 10 to 12 category and the highest scoring student in the undergraduate category. And each of you would then receive a prize. We will be announcing who these winners are at the end of today's event. So you're going to have to stay tuned to hear if you won a prize in that category, and of course to find out what your prize will be. So stay tuned for that. All right. I now have great pleasure in introducing you to our next speaker. And that is Professor Magendran Govender. I see Prof is here. Video on. Okay, so he's ready to go. So let me, perfect, all set. So Prof. Magendran Govender holds a PhD in theoretical physics from the University of Natal. He is presently a full professor of mathematics at DUT. His research interests include stellar modeling in general relativity and modified gravity, extended irreversible thermodynamics, dissipative collapse, and conceptual foundations of quantum physics. All super exciting and interesting. I'm really looking forward to see the demonstrations and to hear from Prof. Megan Govender about his presentation on the flying circus of mathematics. So Prof, over to you.
Thank you, Dr. Ratilal, Serene. Yeah, thank you for those kind and warm words. And good morning to every single one of you up here. I noticed a few people that I recognize also on the chat. So it's really great. I know it's a Saturday. I'm excited. And for those who know me, I do mathematics in a slightly different way. I like to see sort of the applications around me. And that's basically what my talk's going to be about. So I'm just going to share my screen very quickly. I always said I have a face for radio, so I'm going to get rid of that scary video over there. There we go. That's gone. And I am going to Harry Potter pillow. Yes, somewhere at the back. All right, so let's share my screen. And there we go. Right. So if you look at the title of this talk, it's called The Flying Circus of Mathematics. And I'm hoping that the purists amongst us, I'm talking about the mathematicians, don't feel that I'm making a circus out of mathematics in my approach. And that you would leave here after this little presentation, deeply enriched and also with a sense of wonder, right? So as Dr. Ratilal mentioned, I am at the Durban University of Technology, and I've been there for about, well, almost 9 years now, and I'm in the Department of Mathematics. But let me just remind you that I am not a mathematician proper. Actually, I have a PhD in physics, all right? But my supervisor, Prof. Maharaj, is actually a mathematician. So yeah, I sort of delve into applied mathematics and physics. So why the flying circus of mathematics or math? Well, many, many years ago, in my undergraduate studies, I was introduced to this book called The Flying Circus of Physics by Professor Joel Walker. Now, I'm going to appeal to every single one of you who's listening here. If you really want to look at reality with a different perspective, or what happens around you in the universe, day-to-day things, and this is the sort of book you want. And it's devoid of mathematics. It has a conceptual approach looking at phenomena that you would encounter. For example, why is the sky blue? What causes the ebb and flow? When you look at tides, for example, simple questions, but the approach is very, very interesting. And most of the results that I explained in the book are actually published in scientific journals. So like I said, it's devoid of mathematics, so it's not technical in that part of it. So my approach to today's talk or presentation is slightly different. I'm going to try and bring in some of the formulae that you're familiar with from school. So we have learners amongst us here today. We also have undergraduates. So you'll be familiar with most of the stuff that I will be presenting to you. But before I do that, I want to sort of perform a little experiment and then go into a little discussion surrounding that experiment. So if I remember, I need to stop sharing. There we go. And then switch on my camera. Here we go. Right. So that's me over here. And you possibly can't hear this, but bubbling in the background, or maybe I should just hold this up. I have my favorite liquid right over here. And that favorite liquid is actually liquid nitrogen. Many of you know I've been working with that for many, many years. Good morning. Good morning. And does anyone know the boiling point of liquid nitrogen? Anybody? The boiling point of liquid nitrogen? We know it's very cold, but like how cold? Somebody just give me a sort of number. Nope. All right. So let me just show you, but also I need to warn you when you're working with liquid nitrogen, this is very important. Especially mathematicians amongst us, make sure you wear protective gear, your eye gear, -1. Okay, there we go, about -196 degrees Celsius. There we go, Shavara. So at -196 degrees Celsius, we have no clue of how cold that is until you put your hand in there, which you shouldn't do, right? Closed shoes, obviously your should be wearing gloves as well. And then what I want to do is just very quickly just pour in a bit of nitrogen. And it's interesting that if you have a look, I'm just going to twirl that around. Could you all see that? Yes. I love this rotation, by the way. It's really interesting, isn't it? And there you have this beautiful cloud. And that cloud is actually not nitrogen. That's actually water vapor because it's so cold. You see, if I put my hand onto that flask, it's actually sticking to my hand. So very, very dangerous, extremely cold. So to give you an idea, we want to compare this to something we know. So at minus 196 is roughly about 200 times colder than an ice cube from your freezer. All right. So the question I would like to ask is, if I inflated a balloon, yes, and then dunk that into liquid nitrogen, what would you expect to happen? It's a very simple question. Anyone? Inflated a balloon, let me just do that very quickly. It will freeze, yes. Anything else? Someone said deflate, so I don't want it to deflate. I basically want to tie that up so the air can't escape. So what we have is just warm gas from my lungs. It's a vapor inside the balloon. And now I'm going to dunk that into the nitrogen. And let's have a look. So science is just based on 3 pillars, right? Hypothesis, you make a guess at something, you perform the experiment, and then you explain your results. All right, so some nice, interesting results. So I'm just going to put that in there. And this is something you'll remember for the rest of your life. So I just got this on the slide because I don't want to hold that. And you'll notice something intriguing taking place. So the balloon gets smaller like that. So I'm going to hold that pretty close. And inside there, maybe you can't get to see it, but there's a liquid at the bottom, right at the bottom. And then slowly that liquid starts to disappear, right? So there was no liquid, dunk that into the nitrogen, and then you got a liquid in there. And after a while, that liquid's gone and you've got this vapor filling up the balloon, which is really interesting, right? So very few people actually get to see the liquid inside there at the bottom there. So now that you've seen it, hopefully you have. Maybe the balloon was just too dark, the blue itself. Right, so you have the case of it wasn't a deflating balloon, it was a contracting balloon and then expanding because the air did not escape. So again, let me just take away the video and then start sharing my screen. So what's really happening there, right? And there we go. So like I said, for the first time, we started looking at way back in school, we're introduced to negative numbers based on the number line, right? To the left of 0, we got negative numbers to the right. And it's really nothing more than a scaling property. So what I've basically identified here is if you have a temperature scale, for example, your degrees Celsius, your Fahrenheit, we're familiar with negative numbers. We spoke of minus 196 degrees Celsius. People are also familiar with negative bank balances. And the worst thing you could ever do is have a negative sort of figure here owing these fellows over here. So we encounter these things in everyday life. Let's put it that way, these negative numbers. But for the first time, you get to see an experiment, right, where this cooling is taking place. So how do we relate this to what we learned in school? I like these reactions. So we know the ideal gas law, PV equal to nRT, for anyone who's done a little course in grade 11 on physical science. And what you'll notice with that is if the thermodynamical temperature, T on the right-hand side, goes to 0 Kelvin, it forces the pressure and volume to also go to 0. All right. Now this is not what we saw with the balloon and the liquid nitrogen, right? We didn't see the volume shrinking to 0. What we found was a liquid being created. So that law, that's why it's called an ideal gas law, needs to be modified because there's something missing there, right? And what's missing is really nothing more than taking into account the physical reactions right over here. So maybe the undergraduates studying physics would be familiar with the van der Waals equation. And you notice that we got 2 constants appearing in this equation, A and B, all right? So A basically takes into account the attractive forces between the particles, which the ideal gas law sort of ignores. And B is what we call the volume correction factor. What is that? So if you take the gas particles in school, we sort of tend to think of them as point particles. But we know in reality, they have finite volume. So you can't squeeze them down to 0 volume. So I like the fact that, we make an observation like the shrinking balloon to liquid and then from liquid back to vapor. And then we go back and we modify this ideal gas case to give you something more realistic. All right. So I may be oversimplifying things, but all I'm trying to illustrate here is that we can get more complex formulae appearing based on what we observe experimentally. All right. So you're also familiar with these plots, right? We know we have an ideal gas behavior where the pressure is proportional, say, to temperature. And then a real gas, there's slight deviation at low temperatures. And the reason for that is because of the attractive forces between the particles. If you plot a graph of pressure versus volume, then you'd find that there would be deviation at high pressure. And that's because that the particles themselves have finite radii, hence finite volume. Okay. Came across this interesting problem over here. And I'm always reading and trying to find the fun facts and how I can relate this to what's happening around me. And I guess that's the reason why we exist as well, right? Trying to explain stuff and experience the universe in a beautiful and curious way. It's the falling chain problem. And, you know, you Google this and the name Feynman comes up. Anyone familiar with Richard Feynman? I'm talking about the undergraduates and the learners amongst us. Sorry, I'm not reading the chat. I can just see they are. Yeah, there we go. Excellent. So if you've not heard of Feynman, maybe you should Google this fellow. A very interesting character. And apparently it appears in the Feynman lecture series, right? A wonderful series of books on lectures in physics, mechanics, fluid dynamics, electromagnetic phenomena and stuff. So one of the problems there was the falling chain problem. So you have a chain of length L and mass capital M, right? And basically it's hung vertically with the lower end just touching a scale, like a bathroom scale. And the question is a very simple one. And the question goes like this. When the chain is allowed to fall vertically, right, what is the impact force on the scale? When, you know, the instantaneous impact force when the entire chain hits that scale. And it's interesting that you can actually use, under simplifying assumptions, we are obviously ignoring air resistance and stuff. If the entire chain falls onto the scale, then of course, the weight of the scale, the chain would act on the scale. So you should get at least the weight of the chain, which is m times g. But now as the chain falls, remember, it's impacting on the scale. You can treat that as a collision. And so if there's a collision, then of course there's momentum transfer. And this is very interesting as well, okay? So let's assume we take a small portion of the chain, and that little portion has a tiny mass, call it delta M. The length of that mass parcel, if I want to call it, or link, is delta X. So in terms of the larger mass, it'll just be delta X over L times capital M, right? And then if the chain falls a distance X, as you see over here, then the speed of that would be the square root of gx. And this you can get from a grade 10 or grade 11 physics when you look at conservation of momentum. The momentum associated with that little element, delta M, is now delta M times V, because you recall that momentum, linear momentum, is P is equal to M times V. If I replace my expression for delta M from here into there, and I get this expression, right? Now, delta X, if you want to look at the force, everybody knows that the force, the impacting force, is equal to the rate of change of momentum. This is why I write delta P over delta T, right? And then you've got appearing there at delta X over delta T, which is that instantaneous speed. And if you do that, then you notice from that V, you end up with this factor of V squared, all right? But what is V? It's the square root of 2gx, right? So substitute that, the square roots go away, and you end up with the impacting force. Now remember, by Newton's third law, the scale would exert an upward force on the chain. The chain would exert a downward force on the scale, and that impacting force is given by 2gx over L times m at any instant. But if the entire length falls through and impacts, then x is equal to L. And so what we get, apart from the weight, which is m times g, we also have this impacting force here, which turns out to be 2mg. So the total force measured by the scale should be 3mg. All right. So like I said, now I'm making very simple, there's lots of simplifying assumptions. Yeah, there are lots of them out there. Start off with Joel Walker's book, right? Try to Google that. You can also, I spend a lot of time Googling things like fun physics, and a lot of the work that I follow is by actually Richard Feynman. So try and have a look there. Okay. So this is a straight vertical chain falling and impacting on a horizontal surface. Like I said, it's still a very idealized problem. Okay, but you can use some simple mathematics to work out the force. Now, what I came across was something very interesting and intriguing. And is, some of you would have seen this, and that is you have a chain, a bead, a chain of beads, and I'm just going to very quickly now cut through to this. So if you just give me 2 minutes, you can watch this video and I'll chat about it.
This falling chain graphically demonstrates basic laws of physics. Rate of change of momentum is the force. Falling beads of the chain do not touch the glass, instead jump in the air amazingly, making a loop. To perform this experiment, you need a 15-meter chain of plastic beads. Coil the chain inside the glass slowly and carefully, making sure that the chain is not entangled. Now take a bead on the edge of the glass that is moving up and will shortly change its direction to move down along with the change. Now since the chain is falling down, the change of the momentum of this bead is immense. And this change is happening over a very short period of time, which will require an immense force. Since there is no large external force other than gravity, the beads make this wonderful large loop so that the change of the momentum is gradual. And that's why beads.
Okay, so I found this video very intriguing and very exciting. So, you know, knowing me, and I think people that know me, I set out to basically try to create this phenomenon and spent many weeks putting beads together, buying lots of jewelry and stringing them together, and found out that it doesn't work as beautifully as this. And I discovered there are other factors that come into play. And maybe some of you here can actually start to investigate it. For example, the size of the beads, the spacing between the beads, all right? And so there's much more taking place in this experiment rather than just have a straight chain falling down onto, say, a bathroom scale. All right. So I'd like to see, you know, some of you youngsters pursuing this and probably coming up with a nice explanation for this. I think there's a TED talk actually based on this falling chain problem as well. So very intriguing. But notice here again, we also got to take into account air resistance in some sense. So it becomes a more complex problem. All right. So let's just see if I go to the next one. Okay, here we go. So now this is, I'm not sure why my camera is on there. So this is where, you know, Serene mentioned about extended irreversible thermodynamics or thermodynamics. So for a long time, I've been investigating heat transfer in stars. So it's a dissipative process within Einstein's theory of gravity. And if you're going to make this, keep it very simple, you have, say, for example, a source of heat, a candle, it could be a Bunsen burner, and I have a metal rod. So you notice that the end closest to the source, the heat source, would heat up, and gradually what would happen is the rod will start to warm up through conduction. So what happens is you have what we call a temperature gradient. And this is given by Fourier's law, a well-known Fourier's law, right? So you got heat source on the left, and yeah, dt dx is what we call the temperature gradient. K, very importantly, is the thermal conductivity. So that basically looks at the nature of the material that we are investigating. And A is the cross-sectional area, if you look here, right? So basically, you got temperature T1 being greater than T2, then you have a flux, right, across that. Now, what's interesting and intriguing here is if you take away the heat source, if I take away this Bunsen burner or the candle, what Fourier's law tells me is if I make the left-hand side 0, then the right-hand side should instantaneously become 0. So what this means is that dt dx, which is the temperature gradient, vanishes instantaneously. So in an experimental setting, if we have a temperature gradient, say it's warmer closer to the source and cooler further away, take away the source, what this law tells you is the temperature sort of reaches equilibrium instantaneously at each point, the gradient vanishes. Now, if that system is as large as the universe, or very great distances, then you'd find that, you know, these thermal signals have to propagate faster than light. And if you believe in causality, like most of us, then we'd say that this formula is sort of non-causal, okay? And what we'd expect is when you remove the heat source, that the gradient should gradually disappear and thermal equilibrium should be achieved. And so this basically forms the basis or part of my research as well over a long period of time. In fact, so what we do is we basically just model stars spherically symmetric. I might be oversimplifying things here, but I just want to keep it more conceptual. And if the star is radiating energy in the form of a heat flux, and the heat flux is basically due to neutrinos traveling outwards, you'd find that the outside is not empty. So we have a special solution in general relativity that describes that outward solution. But we were concerned with heat transport inside the star, from the center outwards towards the core. And you'd find, if you look at this equation in the middle here, this one over here, if I remove this term, then it's your normal Fourier equation, which is non-causal, right? But we added an extra term over here. This term here involves what we call a relaxation term, right? And why am I saying this? Maybe a little bit of inspiration for people sitting amongst us. So in the year 2001, it almost seems like the age of the dinosaurs now, a colleague of mine and myself decided, well, let's try to solve this equation and try to get a feel for how the temperature varies within a star. And it turns out when we write this out, the A's and the B's are not cross-sectional area, the gravitational potentials of the star. And we were only able to integrate, solve this equation for two cases. One was sigma equal to 4, and the other one was a very simple case, sigma equal to, 0 and 4. 0 is very idealized. It tells me that the relaxation times are constants. But in a star where the density varies, you'd expect variation in the relaxation time and also the mean collision time because of the mean free path. So I'm just putting it out there. Sometimes you sit here and you get inspired and you say, well, I want to solve this. And I'm hoping I'll leave that with you and say, right, maybe try to solve this for different values of sigma. But here's the bad news. There's also another piece to this equation that we've left out. So this is called the truncated equation, a simplified equation. Yet we still can't solve that, right? So that's my challenge, or some people would call homework for the weekend, right? So it's something that you may want to pursue. And that's basically it. If I look at my time, as I was mentioning to Dr. Ratilal, if I'm not stopped, I will continue and we'll take up your entire weekend. So I want to say thank you. Hopefully I've given you just a little bit of an appetizer of what I do and how I see mathematics and its relevance to not just the universe, but to reality itself. And if you are interested in collaborating or you have questions, there's my email address. You can always contact me and I'll be interested in entertaining your questions. Thank you so much.
Thank you so much, Prof. I think if I can speak on behalf of the audience with their reactions and the comments in the chat, this talk was beyond intriguing. So thank you for piquing our interest and keeping us engaged. There was a question that you had already answered, and now I think we have time to take another. So Spiwe Madlopa would like to know what causes the falling chain to loop, like in the way we had observed in the video.
Exactly. So if you listen very carefully over there, the looping effect is basically because of the momentum. We tend to ignore the momentum of these individual pieces. I'm going to be quite honest. I was more intrigued in setting up the experiment. And I said, once that works, then I would go and start to look at the physics of this. In the process of setting up the experiment, I bought so much of jewelry. I mean, it's like Mardi Gras. So basically, I have tons of chains, beads and stuff like that. And I almost went broke in the process. But yeah, so I'm actually now trying to generalize from the straight vertical structure to the looping chain. So I feel there's a lot more that causes that sort of loop rather than just say a huge change in momentum. And that's going to be my next little research problem on the side. Okay.
Thank you. Thank you. I
yes.
want to.
And I should also add that this phenomenon was, I think it was actually strange. It was actually discovered by a journalist for some reason, was doing a piece and then came up with this and then became very famous and went on to do the little TED talk as well. So it's out there. You can actually watch it. Yep. Sorry.
Before we close, Prof, we want to ask you about your journey with mathematics and physics, because there are some questions in the chat box. Somebody would like to know as someone who wants to study astrophysics, what are the requirements for university? But perhaps instead of answering that, you could talk about your personal journey. And Trent, we could guide you. If you send us an email, we could then tell you more about the requirements.
Yes. Okay, so very simple. At school, I enjoyed physics. I was useless at sport. Although I do remember way back in '89, it was a soccer final and I scored 3 amazing goals in that soccer final. My team still lost 3-0. So you can figure that out. But if there were social media and there were cameras, there were 2 amazing, beautiful headers and a bicycle kick, which I performed, by the way, against my own team. But I suddenly realized then that I had to pursue something. I enjoyed physics and I enjoyed mathematics, but I was always drawn to the physics. I was always intrigued at looking at physical phenomena and trying to explain that. And of course, the language of physics is mathematics. That's essentially it. And then someone basically convinced me, well, the principal at that time convinced me I should do actuarial science. And so I thought about it and then decided, well, there's no physics in there, so sorry about that. I'm not going to do it. And then went on to register at UND at that time for physics, BSc, and then of course physics honors. And I was really blessed, and I must say this, the people that I studied under at that time in the 80s, well, not 80s, but 90s, sorry, were amazing. And they really motivated me, inspired me, especially the applied mathematicians, the physicists, of course, the pure mathematicians as well. And I was not intelligent, let's put it that way. Far from it, but I worked really, really hard. So we had very bright people, and to keep up with them, I had to work really hard. And I think that's basically it. The secret to success is hard work. It's not about just genius and just natural talent. And as you get higher up in levels, you start to enjoy things because now you start to also not just seek answers to questions, but you can also provide answers to questions when people come up with things. It was highly frustrating when I was at school and asked a question and they said, wait till you get to university. Many of us encountered that. And we got to university and then they said, wait a little bit more. And I couldn't wait anymore. So we started seeking that stuff out. So it's been an amazing journey. I find that UND is my home. It's my first home. I should say that. I shouldn't be saying that. Yeah, that's where I belong. And I've been part of an amazing team of people. And I'm very thankful for that. But like I said, guys, if you want more about what we do, especially in the astrophysics and cosmology research unit at UKZN, you can always email me and I'll point you to the right people. Yep.
Thank you very much, Prof. We appreciate your time today and the wonderful presentation.
Thank you all. Thank you. Bye-bye. Bye.
Dr. Sithole, I now hand over to you. You are muted.
Thank you. Thank you. Before I introduce our next speaker, I do just want to mention that somewhere during the year, we will be hosting a career fest. So some of your questions on requirements for getting into physics or whatever other science career will be answered also during that period. So please make sure you don't miss that. All right, so let me introduce our next speaker. So our next speaker is one of our partners. So he's from one of our partner organizations, Mr. Piet Molati. He is a mathematics science teacher at St. Martin's Schools in Johannesburg. He teaches mathematics, mathematical literacy, and further studies mathematics for grade 8 through 12. In 2021, Mr. Molati became an integral part of the South African Mathematics Foundation, where he serves as the questioning committee for the junior rounds 1 and 2 of the Old Mutual Mathematics Olympiads. Mr. Molati, over to you. Please unmute yourself, sir.
Okay, thank you, Dr. Sithole. Yes, my name, as I've been introduced, is Mr. Molati, and I'm part of the South African Mathematics Foundation. And under South African Mathematics Foundation, we usually deal with Mathematics Olympiad. I don't know if any of the learners that joined us today have participated in one of those, but they are quite very interesting mathematical pieces to be involved in. And we believe that it all starts with you and, of course, the mathematics, right? So if you are any of the things that I'm going to mention here, you might want to register and participate in one of our Olympiads. So we're looking for open-minded learners who like using mathematics for decision-making and you like thinking in a logical way. And I think the biggest one is interest. If you are interested in exploring further mathematics, especially with non-routine questions, then you might want to participate in one of our mathematics Olympiad. Then how do you prepare for the mathematics Olympiad? So we have two types of the mathematics Olympiad. We have the grade 8-2 metric, and we have the South African Mathematics Challenge that is for the younger children, grade 4 all up to grade 7, right? And our grade 8 and grade 9s write two separate papers or two different papers because the grade 8s are still younger and they don't know what the grade 9s know. But going through to round 2, then the grade 8s and the grade 9s will write the same paper. But interestingly enough, the grade 8, grade 10, grade 11, and matrics, they write the same paper for both round 1 and round 2. Okay, so we try to keep our papers not intensely syllabus-based, but we try to just spark the thinking of mathematics, meaning you just need to know general stuff to be able to answer our mathematics Olympiad. We just try to put out there the non-routine questions that everybody can answer with the little syllabus knowledge they have. So I had some few questions prepared, but I decided to take them out because of the time restraints that we have. Now, first I'm going to talk about, as a learner, how do you develop yourself so that you can be part of our mathematics Olympiad. So firstly, and most important thing, you need to visit our website, the SAMF website, and register as a user. And then after they give you your logins, please log in and you will have free access to all our past papers that have been written before. And if you look at those past papers, they are there with questioning and the memos are also there. So you can use that to practice, right? And just like that, you'll be ready to take on our round 1, which will be on the 14th of March for both the juniors and the seniors. And yes, I put Pi there because it's going to be on the 14th of March on Pi Day, right, as Serene mentioned. And this will lead to an improved problem-solving skills, especially with the mathematics. But we all know, I was a student before in metric and I was afraid of problem-solving questions, our level 4 questions. But this will put you in a very, very good position to be able to tackle those level 4 questions. And another alternative will be to visit mytutor.chat and register your account there. We also have a lot of practice problems there under mytutor.chat. So after that, I just want to talk a bit about the teachers' training or the teachers' preparation. I mean, we know that a lot of teachers are afraid of mathematics Olympiads, mostly because they themselves, they cannot solve it. Believe me, when I started being a teacher, and I remember my principal handed me a past paper from the Maths Olympiad, I looked at it, I'm like, yeah, no. This is definitely not for me. I just want to go to class and teach algebra. But you know what? You practice 2 or 3. After some time, you actually get really good at this Olympiad type problems. I mean, now when you give me a Maths Olympiad type question, I know exactly what to look for, whether I should look for a pattern, whether I must apply some principles. So you get better and better. So I would like to encourage our teachers right there to also go and register on our website and look at these past papers. It will help you to develop a teacher problem solving, and you can actually apply these skills to your classroom and use all of these skills that we use to set papers to also set your exam and teach your kids to improve their problem-solving skills. Okay. And also you will be able to prepare them for our round 1 Maths Olympiad. So I think, in my opinion, it's easier for the teacher to register on the website because you can register all your learners all at once to participate in our mathematics Olympiads. And then after that, we usually have more than 50% of our participants from round 1 qualifying for round 2. You only need to get half, guys. You only need to get 50% of your 20 questions. In round 1, we usually have 20 questions. You just need to get 10 of them right, and then you qualify for the round 2, which is going to be a little difficult because round 1 is just multiple choice. But round two, you'll have to provide an answer for that, okay, which is a bit challenging. But if you go through and qualify for round two, which will usually in May, I'm not sure of the date for this year, but it will be somewhere in May, then we are able to identify talent, mathematical talent to be specific, through this round two. And we want to develop talent as the South African Mathematics Foundation. We developed your talent via Siyanqoba lessons, which we provide assignments and camps. Okay, I'll talk a little more about Siyanqoba just now. And learners progress to from beginner to intermediate or advanced level of problem solving. Okay, and you get yourself an opportunity to participate in the Pan-African Mathematics Olympiad or the International Mathematics Olympiad, which is far more interesting. Okay, now what happens at Siyanqoba campaigns? So we have a couple of centers all around South Africa where we invite children and we teach them the non-routine questions. We expose them to what they must expect in round three Olympiad, because you have round three. After round two, you still go into round three, and which is more difficult because in round two, we just want the final answer. But in round three, we want the whole problem solved, right? We want the whole thing written down step by step in round three. So a lot of people found that even difficult. So we have a couple of centers, most of them in Gauteng and some of them in Cape Town. And we usually, as a center, if you go through round two, then we will pay for you to go and attend all these centers so that you can be exposed to what to expect in round three Olympiad. Okay, so I have a quote here. It says, "It is still true that the quality of the education system cannot outstrip the quality of its teachers," right? So if we invest in teacher development, and one generation of pupils after another will benefit from the same teachers who are confident and competent to teach. So that's why we also offer a teacher training under the South African Mathematics Olympiad. So through teachers training, we invite them and we provide hands-on training. We provide a variety of skills and techniques on how to deal with problem solving, and we enhance the teacher's ability. Most importantly, we improve the teacher's ability to solve Olympiads and non-routine questions, because that's what we have mostly in Olympiads. It's non-routine questions. It's questions that you don't normally get in your matric paper or anywhere else. And then in summary, just go to the website and register as a user, log in, access our past papers, and practice, very important. Be like me, practice until you get it. And then you will be able to use that in class. That's for teachers, and you will improve your problem solving skills. Okay, and register for that round one of the Maths Olympiads. Thank you, Alebucha. Thank you for having me. And over to you, Serene.
Thank you, Mr. Malati. So Serene will take over in just a minute. I think she will start working on the quiz. While she's doing that, and before I hand over to her, there is one question that I'd like for you to just really very quickly answer. And the question is, where can lessons for different Math Olympiad principles be taken? So for those who want to improve before taking the actual Olympiad, where can they find extra lessons for that?
Oh, okay. So we do have a YouTube channel you can go visit where we have lessons from the past. So there's a user under South African Mathematics Foundation. There's a couple of lessons there from Dr. Pubal Pile, such an amazing gentleman. And also on the website, we do have a book from him written, 1,000 Olympiad Problems. So it's basically all the skills and all the lessons that you are going to need to participate on the Olympiad. However, the Siyanqoba program is only applicable to students who make it after round two, unfortunately. So yeah, you can access that until you have completed your round two.
All right, thank you so much. Thank you so much for that interesting talk. Olympiads are always a hit. Thank you. Serene, I'm gonna hand over to you now to start the quiz for us.
Perfect. Thank you, Pete, and thank you, Dr. Sithole. So it's time for quiz 2. So let's get to it. It is exactly the same rules as before. So I'm going to request that you apply exactly the same format when you type in your nickname. So remember, just to remind you, the format for your nickname is your first name followed by your grade. It is either 8, 9, 10, 11, 12, or UG for undergrad. So that's what we're going to do. So you need to go to kahoot.it and the game pin is 800917, or alternatively, you may scan the QR code that is visible to you on the screen. So we will wait another 3 minutes as we give you all an opportunity to join, and we will start this quiz promptly at around 10:30. What do you think of that, Lungi?
Yeah, I think 3 minutes is quite enough time.
Once again, I just want to thank Matric Helpline and Lexia Naidu for the Kahoot platform. So thank you for allowing us to host this quiz twice. I think everyone agrees this platform is quite fun and interactive. You get to choose your own avatar, put in your name. There's the sound in the background. I like the interaction on the cell phone as well, right?
Yeah.
So
I'll just read out the game pin again for the last time, Serene. It's 800917.
And I was going to say this time around, 4 questions again, but it's going to be challenging. I really think you're going to need that pen and paper, so please grab it really fast. You've got around 2 minutes to get your hands on pen and paper. Some of the questions you get 2 minutes so that you have enough time to do the calculation before you select the correct answer. But of course, the quicker you answer, the better for you.
Good luck. Really nice prizes up for grabs, so give it your best.
Yes, we have some sponsored prizes from UJ, which includes a bag, a Bluetooth speaker, with a notebook and a pen. We also have sponsored gifts by the Actuarial Society of South Africa. That's actually Take-A-Lot vouchers so that you could purchase whatever you want on the platform. UKZN, Lungi had also sponsored lunch bags, bottles, and UKZN bags.
Nice.
And
yeah.
I really want to know what's in that Vodacom hamper. That's for the lucky draw.
Yeah. I think the winner should send us a picture, right? At some point, just send us a picture of what you got, because we have no idea. So it would be nice for us to also know what is in there. That's a surprise gift.
Yes. They will deliver that directly to the winner of the lucky draw. Yeah. Okay, we'll wait another minute before we hit the start button. So I'll repeat the game pin. It's 800917. 800917.
So remember, if you can't use your name, you can use your middle name, or you can use your surname and your grade, or for undergrads, UG. Okay, luck. Here we go.
Right, I'm about to hit start. Are we all good to go? You could use some reactions, and then Dr. Sitole can tell me if I could hit the start button.
Yes, I see some thumbs up.
Oh, great. Okay. Good luck to everyone. All right, so 4 questions. Quiz 2, question 1. In the picture, each shape stands for a different number. Which number should be written in place of the question mark? So for example, if you look at the picture, moving from left to right, in the first row, you've got 3 squares. The sum of the 3 squares is 18. But if we look moving down a column, the sum of a square and 2 triangles is 14. So you now need to work out what do each of these shapes represent and what will the question mark equal to. Is it red? 10. Blue? 12. Yellow? 14. Green? 16. 20 seconds remaining.
No pressure.
5 seconds remaining. Okay, time's up. And the correct answer was yellow, 14. Okay, let's take a look at what the scoreboard is looking like.
Oh, Mamo. Well done again. Mamo's taking all the gifts today, huh?
Looks like it, looks like it. Let's go on to question 2. This one might be a bit more challenging. Let's see. At midnight, the hour and minute hands of a clock overlap. After how long in hours will both hands overlap again? Is it red? 12 over 11 hours. Is it blue? 11/12 of an hour. Is it yellow? 1 hour. Or is it green? None of the above. After how long in hours will both the hour and the minute hand overlap again? And this is, of course, after they overlap at midnight. Okay, so we have 27 seconds remaining.
Come on, come on. Where are all my primary, all my high school ones? Come on, let's beat these undergrads, huh?
Yeah, let's get competitive.
Come on. Yes.
5 seconds remaining. 3, 2, 1. Time's up. Lungi, did you get it right?
I didn't try. So I didn't go and try. I didn't try the questions.
Okay, so the correct answer was 12 over 11 of hours. All right, so let's go on to question 3. Lungi, over to you.
All right. Today is neither Wednesday nor Thursday. Yesterday was not Friday or Saturday. Tomorrow is not Tuesday or Saturday. What is today? Is today Sunday, red, or Friday, which is blue, Monday, which is yellow, or Tuesday, which is green? So I'll read that one again because it can be a little bit of a twister. So today is neither Wednesday nor Thursday. Yesterday was not Friday or Saturday. Tomorrow is not Tuesday or Saturday. So today is either Sunday, which is red, or it's Friday, which is blue, or Monday, which is yellow, or is it Tuesday, which is green? Time to exercise our brain cells. Sorry, what's that?
No, I was saying it's a logic question.
Yes, this one is a bit of a tough one, but I'm confident that they got it. 5, 4, 3, 2. What is today? And today is Tuesday.
Wow. Okay, so one more question to go. Shall we look at the scoreboard?
Yes, let's.
Is Mamo still at the top?
Is she? Well, she's second. So, and first is Aman. Well done, my grade 11. Well done. Glad to see some high scholars and not undergrads in there.
And we also, it says that up 11 places in Mishle.
Oh, well done, Mishle. Highest climber on the ladder. Well done. Okay, last question. Any 3 integers A, B, and C are given. Which one of the following is always divisible by 3? Is it red, A, B, C plus A plus B plus C? Is it blue, A plus B multiply B plus C multiply C plus A? Is it yellow, A, B, C plus A plus B multiply B plus C multiply C plus A? Or is it green? None of the above.
This is a challenging one.
It is. It is. This one is I won't even try it. I'm not gonna embarrass myself, so I won't try this one. This one is a challenging one.
I'm thinking long and hard.
No, this one is a bit of a So use your pen and paper wisely and try to calculate which one is the correct answer. Red, blue, yellow, green.
We've given them extra time for this one. It requires it.
You can do it. We have a lot of good, all of you here are really good with maths. Otherwise, we wouldn't be waking up on a Saturday morning to join us. So let's see who will answer it quickly enough.
Forty seconds.
We will have quadratic equations for you next year. 20 seconds. Five, 4, 3, 2, 1, and yellow. So let's look at the scoreboard.
Let's look at the scoreboard.
Owen, well done in third place. Mama, you're still in the running, I see. Well done, man. Grade 11. Well done. Good job.
Phenomenal. Yeah, phenomenal. So just to remind everybody, we are awarding prizes in 3 categories. You could, even though you may not be the top scorer today, amongst the 3 top scorers, you could still win a prize. So we're going to award a prize in the grade 8 to 9 category, another prize in the grade 10 to 12 category, and a prize in the undergraduate category. I also want to state, Lungi, that we have a spot prize. So it may be the case that we just have a student who suddenly improved a lot in the quiz, like we noticed Amishle, and they win a spot prize. So
Nice.
there's other opportunities.
Great. Fantastic stuff. So everyone is a winner today. Well done to all of you actually who got the answers correct. Just didn't do it quick enough, but well done. Well done for answering it correctly. So next up on our program, we have our fireside chats. And we have our fireside chats with Dr. Shavara Hansraj. And Dr. Shavara is, she has obtained her PhD in applied mathematics from the University of KwaZulu-Natal. She's currently a postdoc researcher at UKZN, University of KwaZulu-Natal. Her research falls under theoretical and relativist astrophysics with a focus on rotating black holes, space-time decomposition, higher dimensional gravity theories, and stellar structure. So she is going to introduce to us the people she will be having this really wonderful fireside chat with. Over to you, Shpara.
Thank you, Lungi. And good morning, everyone. Serene, when you told me we were hanging out on Saturday, I didn't know you meant this. It's been a fun day. I've loved the program so far, especially all the math we've seen by Dr. Claudette, and I've been watching Prof. Govender from a little kid. Actually, I watched him at my school, and I'm still as excited to watch him today, all these years later. He's just so passionate about what he does. Well, this part of the program is about the student experience, so it's a privilege to speak to all the young minds today, as I guess you'll call me like an ex-student. So I'm going to be introducing you to some students in a little bit, but I thought I'd speak about my experience quickly. Well, these days I stand on the other side of the classroom, kind of like giving the lecture, doing the teaching. But I vividly remember kind of being in your position, with a lot to think about in terms of the future. So let's press rewind, for a bit. Do you remember what career you first pictured yourself in? Like the age-old question, what do you want to be when you grow up? I'm sure the probability of choosing mathematician would be, pretty low, if not non-existent. But if you had to ask a young Shavara about what her idea was of having a career, she would say it would be doing something she loved every day. And I loved watching movies. I'm sure a lot of you do. But I guess you could say I wanted to be a professional like movie watcher. I would shoot like these small review videos on like a camcorder, like I was on a TV show, like how I see on TikTok these days, footage which I'm sure is preserved for my embarrassment in the future. Yeah, I just started like binge watching movies, and then I met an interesting character. No, like an actual character. I'm talking about Buzz Lightyear. Okay, so the Space Ranger who works for Star Command, protecting the universe from the evil Emperor Zurg. I wanted to be a space ranger as well. And I believe this is where my curiosity about the universe kind of started. Yeah, I think it just basically kept on growing. And I grew up around the influence of math. And over the years, I took a liking to kind of both math and IT. So my biggest influences were, of course, the brilliant scientists, Prof. Stephen Hawking and the tech visionary Steve Jobs. For film references, you can see The Theory of Everything, which is in 2014, and Steve Jobs 2015. Now, although I, no longer with us, they left behind a stellar, legacy. And I got my hand on Hawking's book, Brief History and Time. Of course, at that age, I understood practically none of it. I mean, I feel like at this age, I'm still learning. But at that age, I understood practically none of it, and neither, were there any like Spark Notes or like a version for dummies. But I was deeply fascinated by the kind of words that were mentioned in it. Things like stars and space and gravity. It was also the first time I saw the words black hole, which is something that I study about extensively today. So I wanted to tackle real world problems, answer fundamental questions about the universe, basically just be like them, I guess, do something great. And so I took Steve Jobs' words to heart, where he said the only way to do great work is to love what you do. Generally, that would be like follow your passion. And so all signs are pointing to math and IT. And so off I went to study for a Bachelor of Science in Applied Mathematics and Computer Science at UKZN. And in taking this degree, a science degree at UKZN, it gave me exposure kind of to other scientific areas, just in case there was another spark that was ignited in me, and then I followed that direction. But still, I guess, after all, mathematics was still my anchor, and it's provided me with a plethora of opportunities. I think, sometimes, whether in my field or in others, it's hard to see, sometimes sometimes past the hard exterior shell of mathematics and kind of delve into its beauty. I mean, I get it. I too had to learn all those theorems and calculus and trig, whether it's in high school or as an undergrad, which never gets easier. But amidst all of that, I remember like kind of beaming when I learned about relativity, which explains the relationship between space, time, and gravity, and the Einstein field equations during a general relativity honors module, which is something that you do after undergrad if you want to study further. I think sometimes there's this roadblock where we can view these concepts as kind of like far removed from us, or maybe like too complicated. You could think there's stars and black holes out there, and but maybe like they don't matter so much because I'm never really going to encounter them or like work with them. But the thing is, you actually can. I'm not sure how many of you have seen the movie Interstellar. Christopher Nolan directed it, so I'm sure there's a couple of Nolan fans out there. But do you remember the famous black hole scene? Essentially, there was a scene where they were all going towards a black hole. But essentially, for my PhD thesis, we conducted a mathematical exploration of the rotating black hole. And we came up with these geometrical equations. And essentially what these equations tell us is how an object, like if you picture the spacecraft in Interstellar, it's going towards a rotating black hole, how the spacecraft would stretch, twist, rotate, and deform as it gets closer to the rotating black hole. Basically studying how the space and time around the black hole distorts as you get closer. And the study was conducted right here in South Africa, in fact, at UKZN. So anything is possible. So, looking back, if you told me that I was going to be studying black holes when I first picked up Hawking's book and I saw the words black hole, I'd have thought you were kidding. If you told me while I was studying circle and triangle geometry in high school that I'd be studying the geometry of stars, I'd have thought you were joking. And, to be sitting in the auditorium listening to Professor Stephen Hawking deliver a public lecture at the University of Rome, I'd find that unimaginable. But it happened, and I'm so glad that it did. It happened because of the opportunities that mathematics gave me to not only dream, but also to realize those dreams. Now I'm spending my time at UKZN's dedicated Astrophysics Research Center. So if anybody's interested, we've got a dedicated center, and I'm studying gravitational collapse in higher dimensions. I'm not sure how age appropriate Oppenheimer, the film, was, but if you saw it, then you already know more about what I'm studying right now than you think. So yeah, before moving on, I of course want to give a huge shout out to all the students that are watching from UKZ and Howard College and the Peter Maritzburg campuses. It's great to have you guys with us. And now we're actually going to the student bit. So I'm an ex-student, but we're going to go to the current students. And let's now hear some on-the-ground experiences from some students here at UKZ and Westville. So we're a few weeks into the semester of 2024, and we have with us Linda Sequasha and Emma Hodgson. Hi there, guys. How have you been enjoying the program, Emma?
Hello. I thought the program was great. Like you said, as an applied mathematician, sometimes proofs are not our favorite thing, but I think the talk on magical numbers and how the doctor proved those was really, really great.
Love that. I totally agree. And how are things with you, Linda?
Hello, everyone. Hello. Thanks for the introduction, Dr. Ansraj. I hope you all are enjoying yourselves thus far, especially the students. I feel as if the events are most likely dedicated to us. I really liked all the events actually because they were more youthful and enigmatic. I also enjoyed the quiz as they were a good way to engage, to help us engage as students. So thanks again for the introduction, Dr. Ansraj.
Thank you, Linda. Yeah, I think I have to agree. I was also taking a bit of time answering those quiz questions secretly. But now that you've met, to tell you more about them. So Linda is currently a third-year student taking the math module Real Analysis, which basically deals with the behavior of real numbers, functions, sequences, and series. His short-term aspirations include studying artificial intelligence and honors. And in the long run, he aspires to be, self-employed, have some free time to explore and do things he loves, and also while contributing to the betterment of life. So those are all noble pursuits. One fun fact about him is that he enjoys playing chess, which he says is mostly due to him enjoying things that challenge his thinking. So it seems you've always loved challenges, Linda. Did you always find mathematics a challenge? That is, when did you start to love it?
So I took mathematics and science in high school. And as a side note, I didn't quite enjoy mathematics fully back then. Mostly it was due to me struggling with anything related to proofs, like proofing techniques, anything, like I'd get a problem with it. But now to me, mathematics is more than just a field. It's more of a language and a way of life. And I enjoy it mostly because it challenges my intuitive my intuitive thinking and critical thinking. It's like you said, like I enjoy challenges. Yes, I really do. Well, I recently embarked on a journey to truly appreciate mathematics, and the significances of it. It was last year, and the person who was responsible for sparking back that flame of exhilaration was actually one of our hosts today. It was Dr. Serin Ratiral, and I thank you so much for that.
Love that. So the love for mathematics, I guess you could say, is a recent development. So let's hear from Emma now. A fun fact about Emma is that she loves reading crime and thriller books in her spare time. Hey, Emma, I read a book title the other day that I think you might be interested in. It's called Pythagoras' Revenge, a Mathematical Mystery. So definitely put that on your book list. And Emma started studying, yeah, Emma started studying a BSc degree in physics and chemistry at UNISA, and then she transferred to UKZN in 2023. And after that, she realized she enjoyed mathematics a lot more than chemistry. And so she changed her majors to applied math and physics. I love when people follow their heart and their passions. Nothing wrong with changing course a little bit. And her plan is to continue in academia and get her PhD in mathematics, applied mathematics. So Emma, to want to actively pursue mathematics in the case that you feel strongly about it, what does math mean to you?
Mathematics has always been one of my passions. I did AP Maths at school, and I remember loving maths from a young age. But I would say AP Maths is where my love for the subject really started. I started studying a physics and chemistry degree because I wanted to be a maths and science teacher and see the love in students as well. But it was not long after I started my degree that I realized my passion for mathematics and problem solving was even greater than I could have imagined in high school than I could have imagined in high school. And that is why I switched my majors. Maths has been very fulfilling for me.
Yeah, that's lovely. I think fulfilling is a good word. But I'm sure something really exciting that happened to you guys was being at the South African Mathematical Society Congress meeting last year. I'm sure it was a fun experience as undergrads. What was that like, Emma?
The SAMS conference was amazing, and I'm truly grateful that Dr. Rothelol decided to invite Linda and myself. everyone was really friendly and very happy to talk to us about their research and give us some insights, and asked a lot of questions about my aspirations as an undergrad. So that was great, because in third year and honors, you have to decide what field of mathematics you would like to start getting into. And I only had a faint idea of what I wanted to continue with. But after I attended a lot of talks in different sections at the SAMS conference, and this really helped me decide that I want my area of focus to be graph theory and differential equations. The conference also inspired me to continue with my studies and aim to achieve my PhD one day.
Yeah, I love the clarity that you got from that experience. What about you, Linda?
Thanks again for the opportunity. Firstly, as an undergraduate, I'm very grateful for such an opportunity. It was very amazing. The SAMS Congress exposed me to many mathematicians doing research in all sorts of topics. They were all very wholesome too. The experience emphasized to me that they're just like us. What sets them apart though from the norm is their discipline and love for the subject. I attended a variety of talks back in SAMS. The one that stood to me the most was by Professor Bernardo Rodriguez. It was about finite groups, touching on topics such as linear code, homomorphisms, etc. I felt it was more related to computer science, and as I asked most people there, they also told me that yeah, finite groups are related to computer science. But also the topic was very, very comprehensible to a certain extent, of course, as I'm an undergraduate. Not to forget other interesting talks, such as one by Professor Janelitze and also Shimon from our university. And there were very, very many more others that were interesting.
Yeah, that must have been very inspiring to see how all of the math comes and like connects in different ways. And I'm sure you learned a lot of fun things about different topics in math there. So if I can quickly ask, what is the coolest thing that you've learned in your math journey, Emma?
I think it's very hard to say what the coolest thing in maths is. So as an applied mathematician, you do lots of real world applications, and I think this is what I enjoy best. But I'd have to say one of my favorite things I've learned so far is mathematical modeling with Prof. Hansraj. This is where you use maths to predict the outcomes of populations, diseases, or viruses, or many other things that I probably haven't even studied yet. Um, and I'm sure you are well aware that during COVID, there were graphs showing when the spreading of the virus was getting worse with the peaks, and then how we had to flatten the curve. So this real world thing is all maths and all the mathematicians using what their calculations to predict what was going to happen with the disease or virus. Yeah.
So true. I mean, that's such a practical application of mathematics. How about you, Linda?
Well, I enjoy consuming content by 3 Blue 1 Brown. He's on YouTube. And he has a playlist named The Essence of Linear Algebra. And the coolest thing that I've learned in maths must be him explaining the concept of vectors, specifically how he applies the concepts of linear transformations and a little bit of programming to aid him in animating the videos he uses to explain the concepts. That, from my perspective, was very cool because it shows us the application of mathematics in like practical fields.
Yeah, I think I also follow quite a few YouTubers. I love personally, I love Dr. Becky. So she calls herself the friendly neighborhood astrophysicist, and she explains like all the observations from like the James Webb Telescope. So I work in theory, so I'm not so clued up about observations that much, but that's how I use it to like keep up to date. I was the other day watching a video on jellyfish galaxies and what that means. I thought that was really cool. So just do check out those channels. Now, Linda, you've had an interesting journey ending up with you loving mathematics. So what would you like to say to all the students out there as encouragement if they're facing challenges?
To all the students that are wishing to do mathematics and to those who have already convinced themselves that they are going to do the subject, I encourage everyone of them to give it time and enjoy the process of learning. They must not fear mathematics, rather they should accept it as a challenge and be open-minded about learning. Ask your peers and people in front of you about complicated topics also. In any subjects in general, I'd advise that you view it as a challenge rather than it being difficult and undoable for you. And trust me, I've been in many places where I also couldn't grasp things, like I tried to learn and everything. But like with consistency and the right mentality, anyone can prosper.
Yeah, I mean, that's so true. I think keep persevering. That's great advice. And a lot more events that Dr. Rathilal hosts, you know, they are revision sessions designed to help high school students. So be sure to attend those. And what words of encouragement would you like to say, Emma?
I think mathematics is one of the most fulfilling and eye-opening subjects you can take. It gives you an amazing sense of achievement and problem-solving skills. There's nothing more rewarding than tackling a difficult maths problem and finding the solution on your own. I have tutored a lot of people in maths in the past, and it can be tricky for some, but I've also seen that once people start to enjoy the mathematics and put a lot of effort into it, they succeed. I've had students in the past who are having difficulties with mathematics end up studying engineering and other degrees that involve maths, and I think this is amazing and encouraging for everyone around them. But I really hope after hearing everything today that you will consider a future in mathematics, because once you have made that decision, you will never look back.
Yeah, I think you said it best. Actually, I have no doubt that both you and Linda will have bright futures with mathematics illuminating it, and so can you all. So thank you so much. It's been a lovely day. Thank you.
Thanks for having us. Thanks so much.
Thank you.
Over to you, Dr. Lungi.
Thank you so much, Shavara, and thank you, Linda. Thank you, Emma. That was a really interesting fireside chat. And you guys have a lot of hearts and all these other exciting emojis that are coming through, really further affirming how interesting this really was. And I think a lot of the participants learned a lot from it. I think we've reached the time when we're gonna say goodbye. But before we say goodbye, we're definitely gonna announce our winners from the 2 quizzes. Before we do that, I do really want to thank all our sponsors, our partners. Thank you so much for the support and the sponsoring of gifts. And Serene, I think we can announce the winners for the first quiz, right?
Yes, I'm excited to do this. So I'm going to change a slide and you go ahead, Lungi. You take over for quiz 1. So quiz 1 is all yours. There we go.
For quiz 1, all right, it's coming through, right?
It's supposed to come through. Okay, let me this way. Here we
There we
go.
go. Great. Okay, so for quiz 1, we have Holeng from Spark Randburg High School. Well done. Congratulations. So you will just have to do what we told you to do so you can get your gift in the mail. Congratulations. Then we also have what? Can I even see? Sikuniseko. No, it's Sikuniseko from Hillcrest High School. Congratulations and well done. The next category, the undergraduate category, we have Mamo from the University of Witwatersrand. Well done, Mamo.
Okay, so how do we claim your prize? So to claim your prize, you can send me an email. My email address is ratilalc@ukzn.ac.za. You're going to need to send me your full name and surname, the name of your school, the prize you are claiming, make that clear. We will, of course, verify this. And then your delivery address and contact number, because this is needed for the courier. So I will put up these details again at the end. We still have more prizes to announce. If, for example, you've forgotten my email at some point, you can just go back to the original IDM poster. Both my email and Dr. Lungile Sitole's email is on the poster. So you simply contact one of us with this information. Okay, quiz 2. So we've got the grade 8 to 9 category. And the winner is Adam from Alexander Sinton High School. So Adam, you win a 500 Rand Take-A-Lot voucher sponsored by the Actuarial Society of South Africa. In the grade 10 to 12 category, congratulations to Aman from Kingfisher High School, once again winning a 500 Rand Take-A-Lot voucher sponsored by the Actuarial Society of South Africa. And then we all know who's winning the undergraduate category. That was Mamo from the University of the Witwatersrand. Congratulations, Mamo, because you've won 2 prizes for both quiz 1 and quiz 2. So you also get to take away the 500 Rand Take-A-Lot voucher. I did mention before, Lungi, that we've got a spot prize and we've got the Vodacom prize, the lucky draw. So let's see who the spot prize goes to. And the UK's Swap Prize. Lungi, go ahead.
So the UKZN Swap Prize goes to Khadija, grade 11 from Ispingo High School. Well done to you.
So she gets the UKZN bag, lunch bag, and the bottle. And now the lucky draw winner, Taku, grade 10, Sasselberg High School. Congratulations on winning the Vodacom hamper. We will, of course, be sending this to you, and we look forward to receiving a photo to find out. Everybody wants to know what's in that. So a reminder to everyone, how to claim the prize. Send me the email, ratilalc@ukzn.ac.za. I need your full name, surname, the name of your school, the prize you are claiming, your delivery address, and contact number, which will be supplied to the courier so that it can be sent to you. Okay. So that's it from my side, Lungi.
Yeah, well done. And thank you all for your participation. Thank you all for playing. And for those of you who struggled, practice, 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 practice. That is the only way to succeed in mathematics. And I think from us, with love to you, thank you for joining us, and see you next year.
Yes, thank you. Thank you, everyone. See you next year.